Hi there. One last little trick, if you like to call it that way, I wanted to show you about electromagnets. So first of all, electromagnets have this nice thing that you can actually turn them on and off, right? You've seen that before. It's not something you can do with permanent magnets. Permanent magnets are, as the word suggests, permanent. They always are doing what they're doing. Their strength pretty much is unchanged. I mean, I think permanent magnets do lose their strength a little bit over a long time, but they are what they are. And if you drop them a lot of times, that's bad for the magnets. But overall, they are permanent, as the word says. They always keep your notes on the refrigerator, which is a nice thing. However, in the junkyard, when you pick up scrap metal, ferromagnetic material, and you want to let it go, obviously you want to be able to turn it off, right? So in that junkyard, the electromagnet turns on, attracts the magnet or the ferromagnetic material, and then you turn it off, and then it would drop. So that's a beautiful thing about it. Now there's another thing, and I haven't shown you that is, and let me go back for one moment. So here we see that the electrons are going in a certain direction. All right. Now you can see the positive side of the battery is on this side. That's always where the little thing sticks out, and this is the negative side. If I go to the other side, this program turns around my magnet, or my battery, excuse me. And now what you see is the positive side is there. The electrons are going the other way. All right. And that switches the polarity. All right. So whatever was the red, if that's the north, if that was here, then it's now switched. So let me go back again. Here we see, actually go back to 2-volt, well, it doesn't matter. You see the red is pointing that way. If I go to the other side, the red points that way. And it obviously has an effect on the compass that's nearby as well. All right, it doesn't change the field strength. It just goes the other way around, actually. So you see that? It's pointing, the red is pointing that way. And if I switch the other way, it's pointing the other way. So that is what we mean. We can flip the polarity. All right. So we can flip the north and the south pole of our electromagnet by changing the direction of the current. It's not something we can do with a permanent magnet. All right. So there's another trick. One disadvantage, which is a result of the advantage as well, is that obviously this magnet does not operate unless there is some power given to it, right? It needs electricity, so it needs energy to become this electromagnet. As soon as we stop the energy, we stop the voltage, it is not a magnet anymore. So that's, I would say, is a strength and a weakness. You can turn it on and off, but yes, it also costs energy to run this electromagnet. And that's all. So summarize that on your slide.